Ever wondered why the moon, a celestial body some 238,900 miles away, can have a profound impact on our planet's oceans? It's a question that has fascinated scientists and laymen alike for centuries. Our moon, seemingly small and unassuming in the night sky, holds an incredible secret. It's not just a passive spectator in our earthly affairs. No, it's playing a vital role, subtly shaping our world from afar. The moon's secret lies in its gravitational pull. This invisible force reaches out across the vast expanse of space, making its presence known here on Earth. Its touch is gentle, yet powerful enough to cause the oceans to rise and fall in a rhythmic dance we know as the tides. So, how does this celestial dance partner of ours work its magic? How does the moon, despite being so far away, influence the ebb and flow of our oceans? In the next few minutes, we'll unravel the mystery of how the moon influences the ocean tides on Earth. Gravity. It's not just what keeps us grounded on Earth. It's also the invisible force that tugs at the oceans, causing tides. Now let's consider gravity as a cosmic puppeteer, pulling the strings of our celestial bodies. Just as the puppeteer holds sway over the puppets, the moon, through gravity, has a profound effect on our planet. This force extends far beyond our atmosphere, reaching out to the moon and influencing the world's oceans. The moon's gravity pulls at the Earth's water, creating a sort of stretching effect. This stretching is most evident in our oceans. As the moon orbits around the Earth, the side of our planet that is closest to the moon experiences a stronger pull. This pull causes the ocean to bulge outwards, creating what we call a high tide. But here's another intriguing phenomenon. At the same time, there's also a high tide on the opposite side of the Earth, farthest from the moon. You might be wondering, how can that be? The moon's gravitational pull is weaker there. Well, it's all about inertia. Water, like all matter, has a tendency to keep moving in a straight line. So, as the Earth spins on its axis and the water is pulled towards the moon, the inertia of the water on the far side of the Earth causes it to bulge outwards too, creating another high tide. In essence, the gravitational dance between the Earth and the moon causes two high tides and two low tides each day. The moon's gravity pulls the water towards it, causing a high tide on the side of the Earth facing the moon, and the water's inertia causes a high tide on the opposite side. Isn't it fascinating how these celestial forces interact to create the ebb and flow of our oceans? These daily rhythms of the sea, so essential to marine life and coastal communities, are all thanks to gravity. So, it is the moon's gravitational pull that causes the oceans on Earth to rise and fall. But how often does this happen? The moon doesn't just sit still in space. It orbits around the Earth, and it is this orbit that dictates the rhythm of the tides. Imagine a cosmic ballet, where the Earth is the dance floor and the moon, our prima ballerina. Now, the moon doesn't just twirl aimlessly. No, it follows a distinct path, an orbit circling the Earth about once every 27 days, 3 hours, and 43 minutes. This is known as a sidereal month, the time it takes for the moon to return to the same position in the sky relative to the stars. But here's the catch. The Earth isn't just a passive observer in this ballet. It's spinning too, completing a full rotation about once every 24 hours. This rotation, combined with the moon's orbit, leads to a fascinating phenomenon, the tides. You see, as the moon orbits, its gravitational pull on the Earth changes. When the moon is directly overhead or on the opposite side of the Earth, its pull is strongest. This strong pull lifts the water slightly, causing a high tide. However, as the Earth spins and the moon moves along its orbit, the moon's pull weakens. The water level drops, leading to a low tide. And then, as the moon comes back into position, the pull strengthens again, and we have another high tide. This cycle repeats, leading to 2 high tides and 2 low tides approximately every 24 hours. But the dance doesn't end there. The moon's orbit isn't a perfect circle. It's an ellipse, which means the moon's distance from the Earth changes throughout its orbit. This variation adds another layer to the rhythm of the tides, causing them to be higher or lower, depending on where the moon is in its orbit. So the dance between the Earth and the moon creates the ebb and flow of the tides, a rhythm as old as the moon itself. The moon, our silent partner in the sky, plays a vital role in the daily drama of the tides. This celestial body, hanging in the void of space, exerts its influence over the Earth in ways we often overlook. But if we take a moment to truly understand, we'll see that the moon is the master puppeteer of the ocean's ebb and flow. Let's take a quick rewind through our journey of understanding. We started with the moon's gravitational pull, an invisible force that reaches out across the cosmos to touch us here on Earth. This pull is strongest on the side of the Earth directly beneath the moon, causing the water there to bulge outwards, creating a high tide. But interestingly, there's also a high tide on the opposite side of Earth. This occurs because the Earth itself is also pulled toward the moon, leaving the water on the far side behind, creating another bulge. We then explored the moon's orbit around the Earth. This orbit is not a perfect circle, but an ellipse, and this eccentricity results in varying gravitational forces, and hence varying tide heights. When the moon is closest to Earth at its perigee, its gravitational pull is stronger, leading to higher tides. On the contrary, at its apogee, when it is furthest from Earth, the tides are lower. This combination of gravitational pull and the moon's orbit results in the regular cycle of tides we see on Earth. These cycles, these patterns of high and low tides, are not random. They are a celestial symphony, orchestrated by the moon, played out on the Earth's oceans. So the next time you stand by the sea, remember the moon's unseen hand in the ceaseless rise and fall of the ocean tides. It's a cosmic dance of celestial bodies with the Earth's oceans caught in the middle. So while the moon may seem silent and distant, it is intimately connected to our daily lives, moving the very waters of our planet in a dance that's been going on for billions of years. Title: Unveiling the Mysteries of Ocean Tides, the Moon's Pull. Description: dive into the mesmerizing dance between the moon and Earth's oceans in this captivating exploration of ocean tides. Understanding the dynamics. Ever wondered why tides rise and fall? Join us on a scientific journey as we unravel the secrets behind the moon's gravitational pull and its profound impact on our planet's vast bodies of water. From Neap to spring tides, discover the intricate choreography that shapes our coastal landscapes. The moon's gravitational influence. Explore the moon's gravitational forces and their extraordinary ability to shape the ebb and flow of ocean tides. Delve into the gravitational dance that occurs between Earth and its celestial companion, creating the rhythmic pulse that governs our shorelines. Tide cycles. Demystified. Uncover the different tide cycles and how they influence marine life, coastal ecosystems, and even human activities. From daily high and low tides to monthly and yearly variations, witness the cyclical patterns that connect the moon's phases to the pulse of our oceans. Impact on coastal environments. Discover how tidal movements sculpt coastlines, create estuaries, and influence marine biodiversity. Gain insights into the delicate balance between tidal rhythms and the ecosystems that thrive in the dynamic interplay between land and sea. Neap tides versus spring tides. Distinguish between neap and spring tides and grasp how the alignment of the sun, moon, and earth orchestrates these celestial symphonies. Witness the contrasting effects of these tidal phenomena and their significance in the grand tapestry of oceanic dynamics. Modern observations. Explore how modern technology, including satellite imagery and oceanographic instruments, enhances our understanding of tidal phenomena. Witness the breathtaking visuals that bring these scientific concepts to life, showcasing the beauty and complexity of Earth's interconnected systems. What's next for tidal science? Contemplate the ongoing research and advancements in tidal science paving the way for a deeper comprehension of our planet's interconnected systems. Stay tuned for the latest discoveries and how they contribute to our broader understanding of Earth's dynamic environment. Ocean tides, moon and tides, tidal dynamics, gravitational pull, coastal ecosystems, tide cycles, Neap tides, spring tides, celestial dance, oceanography, earth science, tidal phenomena, ebb and flow, satellite observations, nature science, explore the unknown. Closing script. Thank you for joining us on this enlightening journey into the fascinating world of ocean tides and the moon's gravitational pull. Don't forget to subscribe for more captivating insights into the wonders of our planet. Until next time, keep exploring the mysteries that connect us to the vast and dynamic universe.